Okay, so now question number 2, or the second part of question number 1, is basically you have on Z, part 2 of that question, you have on Z plus, which is basically the positive integers, or you can say the set of natural numbers, the same set. Define star by A star B is equal to A times B. By A star B is equal to A times B, right? So now what this means is that you have this binary operation that you have defined on the set of positive integers, which means that you have basically this situation over here, which is basically star as a binary operation on the set of positive integers. And basically, if this is a function, and this is defined by basically A star B is equal to A times B. So this is the situation that you have. Which means that basically A star B is basically what that is actually the star of A comma B, each A comma B that you can find from in this set, and that basically is going to be is going to have an image. This is going to have an image which is basically A times B, right? Now, if star is supposed to be a binary operation, then of course, then basically this has to be a function. If this is a function, then you can call star a binary operation. So now let's see if that is the case. And if this is if you are to say that this is a function, that means that every member of the domain has to have a unique image in the codomain of the function. The domain of the function becomes this set, which is the Cartesian product of Z plus and Z plus, and the codomain of the function is basically Z plus, the set Z plus. So what I need to do is basically find some element over here, A comma B, and see if that is the case. Any element that I find, and of course you know that I don't have 0 over here, right? So, and I have all of these basically, and I have Z plus is basically this set that starts from 1 and goes all the way up to infinity, 1, 2, 3, and so on and so forth. So that means that at the end of the day you will get these ordered pairs, like for example 1 comma 3, which is going to give you an image like 1 times 3, which is equal to 1 times 3, which is equal to 3, which belongs to Z plus. And so you can say that for every A and B belonging to the set of Z plus, then of course A times B belongs to the set Z plus, and therefore basically star is a binary operation on basically on Z plus. Now the solution, now if I were to write the solution, basically taken from the solutions, I would say that basically the solution, I would say that basically we have on Z plus is defined A star B is equal to A times B. Is defined A star B is equal to A times B. It is not a binary operation, as the image of 1, 2 under star is, no, I'm sorry, I'm reading the wrong place. Okay, so it is on Z plus star is defined by, so let me rewrite this. So we have on Z plus star is defined by, and Z plus star is defined by A star B. A star B is equal to A times B. Okay, it's seen that for each A and B belonging to Z plus, it is seen that for every A and B belonging to Z plus, or for each A and B belonging to Z plus, there is a unique element AB in Z plus. There is a unique element in Z plus. This means that star carries each pair A and B. This means that star carries each pair, or each ordered pair A comma B to a unique element A star B, which is equal to A times B in Z plus. Therefore, star is a binary operation. Therefore, star is a binary operation. So that is the way that you can write it. You can write the same thing that I mentioned in these steps, but this is of course more elegant than the way that I said it. The next part of this question is part 3. Part 3 of this question is on R. Part 3 we have on R, define star by A star B is equal to AB squared. Define star by A star B is equal to AB squared. Define star by A star B is equal to AB squared. Okay. Now, so what it means is that basically we have defined a binary operation on the set R, a binary operation star on the set R, defined by basically A star B. A star B is equal to AB squared. And what that means is that any and of course you can see that this is basically any A comma B that you take in R, in the Cartesian product of R and R, then that A and B will be basically b will be raised to the second power, which is again a real number. Then that real number is multiplied by a, which is a real number. A is a real number as well. So when you multiply two real numbers together, you will get a real number. And so that ab squared belongs to the set R as well. So then that means that star takes every ordered pair a comma b to a unique image in R, which means that then star is a binary operation, right? And so you can say that it is seen that. Now I'm going to just simply write the solution directly. So the solution is basically, it is seen that for each a comma b belonging to R, it is seen that for each a comma b belonging to R, there is a unique element ab squared. There is a unique element ab squared in R. This means that star carries each pair a comma b, belonging to, I could say belonging to, for example, the Cartesian product of R and R, which is basically your domain here, to a unique element a star b, to a unique element a star b, which is equal to ab squared in R. In R, therefore star is a binary operation. Star is a binary operation. That is part 3 of this question. Now part 4 of the same question, I have to use basically what we created before. Okay, so now part 4 of this question, we have basically we have on Z plus define star by a star b. A star b is equal to the absolute value of a minus b. Okay, so we have basically the set of positive integers, and on the set of positive integers you define a binary operation star, and a star b is the absolute value of a minus b. Which means that basically any number that you take over there, for example, which is of course a binary operation, because no matter what a and b are, if the difference of a and b is a negative number, then the absolute value function is going to give you a positive number, and that positive number is going to exist in Z plus, and so that's a function, right? So then you can say that as the solution, you can say that on, move this over here so that I can see properly. As a solution, you can say that on Z plus star is defined by A star B is equal to the absolute value of A minus B. It is seen for each A comma B belonging to, so it is seen that for each A and B belonging to Z plus, there is a unique element. There is a unique element, the absolute value of A minus B, which belongs to Z plus. So this means that basically that star carries each pair A comma B to a unique element A star B, which is equal to the absolute value of A minus B in Z plus. Therefore star is a binary operation. Star is a binary operation. So that was part 4 of this question. Now part 5 of this question is on Z plus again. Define star by A star B is equal to A. A star B is equal to A. So of course this is also a binary operation, because any A comma B that you pick in the cross multiplicate in the Cartesian product of Z plus and Z plus, then of course A is taken from Z plus, then of course, and then star of A comma B is going to be equal to A star B, which is equal to A. So A belongs to Z plus as well. And therefore you can say that basically star is a binary operation. There is no problem with it. So to write it down, is that eraser? Okay. To write it down, you can say that on Z, as the solution, you can say that on Z plus star is defined by A star B is equal to A. It is seen that for each A and B belonging to Z plus, there is a unique element A in Z plus. there is a unique element A in Z plus, and this means that star carries each pair A comma B, to a unique element A star B, which is equal to A in Z plus. Therefore star is a binary operation. Therefore star is a binary operation. Right? So this was the last part of question number 1. Now question number 2, we want to, for each operation star defined below, determine whether star is a binary, commutative or associative. You want to determine star is binary, commutative, or associative. Now, the first part of this question is question number 2, and the first part is on Z, define A star B is equal to A minus B, which is of course a binary operation on Z, because whatever you take in Z, whatever A comma B you take in Z, A minus B is going to belong to Z, so it's a binary operation. Now, for being commutative or associative, of course, it's not going to be commutative, it's not going to be associative. It's going to be associative if you use parentheses or brackets, and of course it's not commutative because A minus B is not equal to B minus A. And it's not going to be associative because A minus B minus C is not equal to A minus B minus C. So that means that this is not associative, and this means that it's not commutative. Okay. Now, to remember what we said about commutative and associative, let's read the definitions one more time. So here we said that the binary operation on a set X is called commutative if A star B is equal to B star A for every A and B belonging to X. That's called commutative. A star B is equal to B star A. So you can see that this is A star B, this is B star A. So this is not commutative. And over here we said that the binary operation star on a set A is said to be associative if A star B star C is equal to A star B star C for every A, B, C belonging to A, which is of course not the case here, as you can see. So now let me write down the solution here. The solution is Okay, so now to write this down, you can say that basically on Z, the solution, you can say that on Z, star is defined by A star B is equal to A minus B, right? Based on what we have here. So it can be observed that one star 2 is equal to 1 minus 2, which is equal to negative 1, which of course belongs to Z, right? And 2 star 1 is the same thing as 2 minus 1, which is equal to 1, which also belongs to Z. But 1 star 2 is not equal to 2 star 1, where 1 and 2 belong to Z, right? So hence the operation is not commutative. Hence the operation is not commutative. I don't remember what I said, but I suppose what I said was actually correct. I'm not really sure. Now about being associative. About being associative, we can say that also we have basically 1 star 2 star 3 is equal to 1 minus 2 star 3, which is equal to negative 1 star 3, which is equal to negative 1 minus 3, which is equal to negative 4. And 1 star 2 star 3 is equal to 1 star 2 minus 3, which is equal to 1 star negative 1, which is equal to 1 minus negative 1, which is equal to 1 plus 1, which is equal to 2. So you can see that basically 1 star 2 star 3 is not equal to 1 star 2 star 3, where 1, 2, and 3 belong to Z. Therefore, hence the operation is not associative. Hence the operation is not associative. Okay, so this was part 1 of this question. Now part 2 of this question is on Q. on Q, define A star B, define A star B is equal to AB plus 1. So of course it's going to be a binary operation, because anything that you pick in Q, any A comma B that you pick in belonging to basically Q times Q, that is going to be, you take those two rational numbers, or those two rational numbers, multiply them together, and then A and B, multiply them together and add 1 to that, so it's going to be a rational number. So it's going to be a binary operation. But as far as its commutative and associative being concerned, you can say that, of course, well, it's going to be commutative, because what you're doing with A and B, you're just multiplying them together. So that in multiplication, the order doesn't matter. So it's going to be commutative. So in commutative, basically what is important is that A star B has to be equal to B star A. But associative, and it's going to be commutative. Associative means that A star B star C is supposed to be equal to A star B star C, which is of course not going to be associative, because you pick, for example, I don't know, 1, 2, and 3, and take 1 and 2 together as A and B. You would get, for example, something like, for example, 1 times 2 is equal to 2, 2 plus 1 is equal to 3, and then 3 star 3 would give you 9 plus 1 is equal to 10. This would be 10. And then A star B star C would be basically 2 star 3, which would give you 6, 7. 1 star 7 would be 8. So this would be 8, for example, for these 3 values. And then, of course, it's not going to be associative. Now, in order to write this down, basically we can write it down this way. We can write it down this way as it is known that A times B is equal to, it is known that A times B is equal to B times A for all A and B belonging to Q. For all A and B belonging to Q. Therefore, which implies that AB plus 1 is equal to BA plus 1 for all basically A and B belonging to Q. Okay, and therefore A star B is equal to B star A for all A and B belonging to Q. For all A and B belonging to Q. Therefore, the operation star the operation star is commutative. Is commutative. And it can be observed that one star 2 star 3 is equal to basically 1 times 2 plus 1 based on what we have here. 1 times 2 plus 1 star 3, which is equal to 2 plus 1 is equal to 3. That's 3 star 3, which is the same thing as 3 times 3 plus 1, which is equal to 10. The exact same example that we picked earlier. And 1 star 2 star 3 is the same thing as 1 star, basically 2 times 3 plus 1, which is the same thing as 1 star 6 plus 1 is equal to 7, which is equal to 1 times 7 plus 1, which is equal to 8. And therefore you can say that 1 star 2 star 3 is not equal to 1 star 2 star 3, and therefore the operation is not associative. Therefore the operation basically star is not associative. It's not associative. Okay. Now that is another part of this question. So the next part of this question is part 3 of this question, part 3 of question number 2, which is on Q. On Q, define A star B. Define A star B is equal to A times B divided by 2. Okay, so basically about this one, on Q you define A star B is equal to A times B divided by 2. So that means that any A comma B that you find in the Cartesian product of Q and Q, so that A and B would basically, that basically means that A and B belong to Q, of course. So then you have two rational numbers, and then you're just simply multiplying them together. So in multiplication, the order doesn't matter. So of course, it is going to be, of course, commutative. But it's not going to be associative. Because then A star B star C would be basically two different numbers, and then you take the star of those two values. You're not going to get associative, but it is going to be commutative. Now, in order to, let me write it down, because my explanation was not very clear, of course. So as the solution, you can say that on Q star is defined by A star B is equal to A times B divided by 2. Now it is it is of course known that A times B is equal to B times A for all A and B belonging to the set Q, and therefore AB divided by 2 is going to be equal to BA divided by 2 for all A and B belonging to Q, which means that A star B is going to be equal to B star A for all A and B belonging to Q, right? Therefore the operation star, the operation star is commutative. Now, for being associative, for all A, B, and C belonging to, for all A, B, and C belonging to Q, we have A star B star C is equal to, based on the rule that we had up here, A divided by A times B divided by 2. So we have AB divided by 2 star C, which is the same thing as basically A times B times C divided by 2. A times B divided by 2. No, I made a mistake here, I suppose. So I have to take this number and multiply it by this number and then divide the whole thing by 2, meaning that this number becomes AB divided by 2 times C, and then divide the whole thing by 2, which gives me ABC divided by 2 divided by 2, which gives me ABC divided by 4. Now if I calculate A star B star C, that is going to be equal to A star, well, B times C divided by 2, which is the same thing as now I have to multiply these two numbers and divide by 2, meaning that I have A times BC divided by 2 and then divide by 2 excuse me, and then divide by 2, which seems to be associative as well. So you have ABC divided by 2 divided by 2, which is equal to ABC divided by 4, which means that basically this is of course star, A star B star C is the same thing as A star B star C, right? Is equal to that, where A, B, and C belong to Q. Therefore, so what I said was actually not right. Therefore, about being associative, about not being associative. Therefore, star is the star is an, therefore star is associative. is associative, right? Now the part 4 of this question, says on Z plus define A star B is equal to 2 raised to the power AB. Now, of course, you can say that it is known that A times B is equal to B times A for all A and B belonging to Z plus. And that basically means that if these two are equal, then you can say that 2 raised to the power AB is equal to 2 raised to the power BA for all A and B belonging to Z plus. And therefore A star B is equal to B star A for all A and B belonging to Z plus. And therefore star is a commutative binary operation. Therefore the operation star is commutative. Now about being associative, if I calculate A star B star C, what I will get is basically A star. Now B star C would be 2 raised to the power B times C. 2 raised to the power B times C. And that is equal to A star 2 raised to the power, so then I have to take this number, meaning that A star B is equal to 2 raised to the power, so I have to multiply these two numbers and then use it as an index for 2. So that's 2 raised to the power A times 2 raised to the power B C, right? 2 raised to the power BC. So which is the same thing as 2 raised to the power A, well, the same thing, A 2 raised to the power BC. Now if I calculate A star B star C, that is going to be equal to A star B is the same thing as 2 raised to the power AB star C, and then I have to write this as 2 and then 2 raised to the power, and then probably write this a little bit differently or down here. So I have to write this as 2 raised to the power 2 raised to the power AB times C, which is the same thing as 2 raised to the power C 2 raised to the power AB. And as you can see, A star B star C is not the same thing as A star B star C, which means that therefore basically is not associative. But here you can use a counter example as well. Here I can say that basically the operation star is not associative. The operation star is not associative, but it is actually better to, it's actually better to if you know that it's not associative, then it's better to use some sort of a counter example, meaning that you pick, for example, 3 numbers, meaning that you can say that it can be observed that basically 1 star 2 star 3, 1 star 2 star 3 is the same thing as 2 raised to the power 1 times 2 star 3, which is the same thing as 2 raised to the power 2 star 3, which is the same thing as 2 raised to the power the product of these numbers. So 2 raised to the power 2 times 3, which is the same thing as 4 times is equal to 2 raised to the power 12. Now whatever that might be. Now 1 star 2 star 3 is the same thing as 1 star 2 raised to the power 2 times 3, which is the same thing as 1 star 2 raised to the power 6, which is the same thing as 2 raised to the power 2 raised to the power what was basically the rule that we had here? Okay, so this was the question. So 2 raised to the power 8 times b, right? So you have 2 raised to the power 8 times b. So 1 times basically 2 raised to the power 6, which is the same thing as 2 raised to the power 2 raised to the power 2 raised to the power 6. Now 2 raised to the power 6 is equal to seems to be 64, I suppose, right? 2 raised to the power 6 is equal to 64. So that is the same thing as 2 raised to the power 64. So here you have 2 raised to the power 12. Here you have 2 raised to the power 64. Which means that then basically you can say that 1 star 2 star 3 is not the same thing as 1 star 2 star 3. 1 star 2 star 3, and where of course where 1, 2 and 3 belong to z plus, therefore the operation star is not associative, right? So that was part 4 of this question. Let's do another part of this question, part 5. Part 5 of this question is basically on z plus on z plus, define a star b. Define a star b as is equal to a raised to the power b. Now, basically, well, of course, since you can say that since a raised to the power b is not equal to b raised to the power a for all a and b belonging to z plus, therefore star therefore the operation star is not commutative, right? Is not commutative. And I'm saying this because a star b would be equal to a raised to the power b, and b star a would be equal to b raised to the power a. Now, of course, and if I take, for example, a as 1 and b as 2, then basically a raised to the power 1 star 2 would be equal to 1 raised to the power 2, which is equal to 1, and 2 star 1 is equal to 2 raised to the power 1, which is equal to 2. So therefore, you can say that star is not commutative. So that is basically, and basically you can say that here where 1 and 2 belong to z plus, of course. Now about being associative, well, we can pick, for example, 2, 3, and 4 as what they have picked over here. So it can be observed that basically 2, 3, and 4, for example, 2 star 3 star 4 is equal to, well, we said that over here, we said that the question starts from here, so a star b is equal to a raised to the power b. So 2 star 3 is 2 raised to the power 3 star 4, which is the same thing as 2 raised to the power 3 raised to the power 4. And this is equal to 8 raised to the power 4, which is equal to 64 times 64 is you can say 2 raised to the power 12, for example. You can call this, for example, 2 raised to the power 12 or 8 raised to the power 4. Now, 2 star 3 star 4 is the same thing as 2 star 3 raised to the power 4, which is basically 2 raised to the power 3 raised to the power 4, 2 raised to the power 3 raised to the power 4. Now 3 raised to the power 4 is equal to 81, that's 2 raised to the power 81. And of course, then you can say that basically 2 star 3 star 4 is not the same thing as 2 star 3 star 4. and therefore star is not and of course here you can say that where 2, 3, and 4 all belong to the set of we were working with Z plus, right? Z plus. Therefore, the operation star is not associative. Now the next part of this question is okay. The next part of this question is on R, part 6. On R, actually on R minus -1, define A star B as is equal to A over B plus 1. So of course it's not going to be commutative, and most probably not even associative. So you can say that basically as the solution, you can say that it can be observed that one star 2 is the same thing as 1 over 2 plus 1. 1 over 2 plus 1, which is equal to 1/3. And 2 star 1 is the same thing as 2 over 1 plus 1, which is equal to 1. Therefore, 1 star 2 is not equal to 2 star 1, where 1 and 2 belong to R minus -1. Therefore, the operation star is not commutative. The operation star is not commutative. Now about being associative, so it can also be observed that for example 1 star 2 star 3 is the same thing as, so we said that A star B is A over B plus 1. We said that A star B is the same thing as A over B plus 1. So then you can say that basically 1 star 2 is equal to 1 over basically 2 plus 1, which is equal to star 3, which is the same thing as 1/3 star 3, which is the same thing as basically 1/3 divided by 1/3 divided by 1 plus 3, which is the same thing as 1/3 divided by 4, which is equal to 1/12. And 1 star 2 star 3 and 1 star 2 star 3 is the same thing as 1 star basically 2 over 1 plus 3, which is the same thing as 1 star 2 over 4, which is 1/2, which is the same thing as basically 1 over 1/2 plus 1, which is equal to 1.5, so that's 3/2, which is equal to 2/3. So as you can see, therefore you can see that basically 1 star 2 star 3 is not the same thing as 1 star 2 star 3, where 1, 2, and 3 belong to the set that we talked about here, r minus -1. R minus -1. Therefore, the operation star is not associative. The operation star is not associative. And that concludes question number 2. We will continue with the next questions in the next video. Thank you.